All right, so a little bit more stuff on the tan function. So state the transformation required to sketch the graph of f of x from g of x. Okay, so again, I sort of rewrite everything so we get everything, rewrite the equation so it's the same form as the original. So the original is just y equals tan of an angle. That's what I'm looking to get. I've got that y expression equals tan of an angle. And so now we can equate the y dashed on 2 is equivalent to the y value. The angle, a half x minus pi on 4, is equivalent to the x in the tan x. So again, once we've done that, we want to rearrange and get what y dash and x dash are equal to. Because don't forget, when we work out, if I get given a series of transformations, I start with x dash y dash becomes, divide by 2 from the y-axis means multiply the x value by 2. Yeah, so I get x dash y dash is equal. So I want to work out what what x dash and y dash is equal to. So from in here, I can see that x dash y dash is 2x plus pi on 4 comma 2y. And from that point, I think it's really easy to tell you the transformations. You could quite possibly, and there's nothing wrong with it, identify it from there. And we might talk about that. So if I multiply the x coordinate by 2, okay, I'm moving from the y-axis. If I add pi on 4 to the x value, I'm moving along the x-axis. If I multiply the y value by 2, I'm moving from the x-axis, that one there. And we can see all that here. 2 out the front is my dilation by a factor of 2 from the x. Pi on 4 inside the function, shifting it in the positive x direction. A half inside the function, okay, it means that it's n on 2. So to get a half inside, I've got f of n on 2 or 1 on 2, which makes the dilation a factor of 2. So you definitely can read it directly from here. So it doesn't matter which way you want to have a go at. Sketch the graph. Well, we know my standard graph. Yeah, and that's the period. All right, so my period for this function is equal to 2 pi. So if that's 0, that's pi, that's minus pi. We shifted everything to the right, pi on 4. So that makes 5 pi on 4 and negative 3 pi on 4. So my asymptotes are at negative 3 pi on 4 and pi on 4. My intercept, instead of being at 0, is pi on 4 to the right. And my y-intercept, well, the significance of tan of negative pi on 8, if I put x equal to 0 into my function, I get tan negative pi on 8, which is equal to negative 0.41. But I've got a 2 out the front, so I've got to multiply it by 2. So my y-intercept is actually 0, negative 0.82. All right. Okay, and now a couple of trig equations we want to solve. Tan function, cosine, sine function, it's all the same process, isn't it? Work out your base angle. We get a root 3 on 3, which is the same as 1 on root 3, which means my base angle is pi on 6. So we know 2x is equal to pi on 6 and 7, pi on 6 initially because I'm in the first and third quadrants. Then I've added another 2 pi at that stage, so I've added 12 on 6 to both of those. Given that I'm between 0 and 2 pi, then divide by 2, and we get 4 valid solutions. Probably this one's just a smidgen premature in that we're looking for a general solution, but that's okay, we can go through the process. We divide, take the 1 on root 3 cos across to the right-hand side, then divide by a cos, and so I get sine x on cos x, okay? That's our process. If ever we have a sine and a cosine present in the one trig equation, there must be a way to get a tan. So the equation is actually tan x on 2 is equal to negative 1 on 3, which is similar to the one previously. My base angle is pi on 6. So if you like, my general solutions, I've gone straight for my general solution here. where because we're moving down into the fourth quadrant, we subtract pi on 6, tidy that up. So I take pi on 6 out the front as a factor, I get 6n minus 1, multiply 2 across, I end up with a pi on 3. So there's my general solution. If you've just got your original solution, if I put n equal to 0, I get negative pi on 3. If I put n equal to 1, I get 6 minus 1, which is 5. 5 pi on 3, etc. Maybe if I put it equal to negative 1, I get negative 7 times pi on 3, etc. All right. So if you found some specific solutions, there they are there. But obviously the next exercise is our more general solution process.